Good morning, maths nerds, and welcome back to Mathematics, where we put the simp into simplifying algebraic expressions. Today we are starting another extension 1 lesson. This one's on inequalities. It's a two-parter, and the second part will be up next week, hopefully. So let's just dive in, shall we? We're going to start off by looking at some quadratic inequalities and also looking at inequalities involving absolute values. Starting off with some quadratics. Here we have find or solve where x squared minus 2x minus 3 is less than or equal to 0. So in the advanced course, you're used to solving these quadratics equal to 0 and finding two answers. Today we want to find where is this quadratic, or where is this parabola, spoiler alert, less than or equal to 0. So the way we're going to handle these is we are going to say to ourselves, all right, cool, I know what this looks like. It's a quadratic and it's got a positive x squared value, which means it's a concave up parabola. Okay, concave up slippery dip. Let's find where its intercepts are, because that'll give us some information about where it's going to be above or below the x-axis, and below the x-axis is less than 0 and above the x-axis is greater than 0. So let's do some cheeky factorizing. Let's set this equal to 0 for now, because we're just going to try and find the two solutions, which are the two intercepts. Bit of a factorize, adding to minus 2 and multiplying to minus 3 is going to give us minus 3 and positive 1. And now solving this expression equal to 0 is going to get us x equals 3 here and x equals minus 1 here as our two values. So we know what it looks like. It's a parabola. We know where it's passing through the x-axis. So a quick little cheeky sketch is going to look like this. So where you're solving an inequality greater than 0, you're seeing where is this parabola above the x-axis, which is this part here and this part here. For this question, we're seeing where is the parabola less than or equal to 0? Where is it below the x-axis? And the parabola goes below the x-axis in these values here. Okay, the dip that's underneath y equals 0. Okay, so greater than 0 above, less than 0 below. So we can see x values between minus 1 and 3 are giving us results on the curve that are down here, which is below 0. That's why our solution is x is between minus 1 and 3. Okay, that's how we write x between minus 1 and 3. So everywhere in here, the x values go into the equation and give us an answer that is less than 0. If you don't like doing this graphically, you can just do this algebraically. You can get your two values and then just find a number in between them, like 0, for example. If you sub 0 into the original question, 0 squared minus 2 times 0 minus 3 will get you an answer of minus 3, and minus 3 is less than or equal to 0. So the values between the two x-intercepts work in this equation. If you tried a number bigger than 3 or less than -1, this would not hold true. So yeah, I like to do it graphically. Some people like to do it algebraically, but everyone's different, you know. Let's do another one, a slightly spicier one. We've got 5y plus 2 is less than 3y squared. Okay, so just like with solving a quadratic equation, with solving a quadratic inequality, it's best to get everything on one side equal to, or sorry, with a 0 on the other side. So we're just going to move this 3y squared across the left to become a negative 3y squared. And me personally, I like to have my squared term being positive. Just makes more sense to me graphically. So I'm going to multiply everything in this expression by -1. So negative 3y squared becomes positive, and these two guys become negative. Don't forget, when you're solving an inequality, every time you multiply or divide by a negative, your inequality sign changes direction. So we're now not looking at less than 0, we're looking at greater than 0. Okay, so this time we have a quadratic. It's got a positive squared value. So again, it's a concave up parabola. And we're trying to see where is it greater than 0, whereas in the last one we were looking at less than 0. So just like last time, we're going to find our two x-intercepts or two axis intercepts by solving the quadratic equal to 0. So you can use the quadratic formula here. You can factorize. If you if you weren't loved as a child, you can use the cross method because that sucks. But anyway, however you solve this, you should either factorize it like this or use the quadratic formula, and you get your answers to be positive 2 here and negative 1/3 y here. Not going into full detail on this factorization because that's I already have a video on my channel about that. If you need to look it up, it's called factorizing non-monic trinomials. Okay, so we get our two solutions. So it's going to look like this. Just pretend in this example that y is x and x is y because it makes more sense graphically. So here are our two intercepts, minus 1/3 here and 2 here. Not exactly the scale, but you get the idea. This time we are trying to see our original problem up here that we solved was where is this parabola greater than 0? Like I said before, greater than 0 means above the x-axis. So we're looking at this arm here and this arm here. Okay, so the endpoints of our parabola, or the bits that are pointing out sideways, these are the values from 2 and up, or minus 1/3 and down. Okay, so when you're in the dip, you're between two values. When you're on the arms that are stretching off forever, you're greater than this value or you're less than this value. So that gives us our solution that y needs to be less than -1/3, so we'd be down here, or y needs to be greater than 2, so we're up here. Okay, any values between -1/3 and 2 are going to be in this dip here, which are less than 0, and we want to be greater than 0. So that's the idea. Anytime you've got a quadratic inequality, just set it up like a regular quadratic equation, solve it equal to 0, think about what the graph looks like in your head, and you can determine whether you are outside your two intercepts or whether you're between them. Or like I said, you can test values if you prefer to do it algebraically, whatever you like. Okay, let's talk about absolute values. First question, if the absolute value of something was less than or equal to 2, what are some possible values of that something? So we know absolute values are an operation that takes a number and gives you the distance of that number from 0. So positive numbers stay positive and negative numbers get turned into positive numbers. So imagine we could have a 2 in here, we could have a 1 in here, or we could have a 0 in here. They would all give us absolute values that are less than 2. But we could also try -1 or -2. If we did the absolute value of -1, it would be +1, which is less than 2, so it works. So what we're seeing here is that any numbers between -2 and +2 are going to hold true in this equation here. If we think about numbers that give us an absolute value of greater than 2, well, it could be 3, 4, 5, 6 up to infinity, or it could be negative numbers like -3, -4, -5 off to -infinity. Okay, so when you have an absolute value less than a number, you're going to be between the positive and negative version of that number. If you have an absolute value greater than a number, it means you're either bigger than that number positively, or you're less than that number in terms of negatively, if that makes sense. So the thing we're going to be using today, if absolute value of x is less than a, it means that what's inside your absolute value is between negative and positive a. If you have an absolute value bigger than a number, it means you're either bigger than the number in the positive sense, or you're less than the number in the negative sense. This is our process for the next few examples, like this one. We have the absolute value of x plus 3 is greater than or equal to 1. That must mean that x plus 3 is going to be bigger than or equal to 1, or x plus 3 is going to be less than or equal to -1. So we're going to have two cases. Here's our first one. Like I said, x plus 3 could be a number that's 1 or bigger, which means that if we subtract 3 from both sides, x could be greater than -2. That's half our solution. Now we'll look at the negative case where x plus 3 could be less than -1, because if, say, x plus 3 was -5, the absolute value of -5 would be 5, which is greater than 1, so it works as well. Hopefully I'm not over-explaining that. Subtract 3 from both sides and you end up with x is less than or equal to -4, and those two answers there make up our solution, so we're going to write both of them. For the next one, a little bit spicier, we've got the absolute value of 2 minus 5x is less than 1. That means whatever is inside our absolute value is somewhere between 1 and -1, but we're not including it this time because we are strictly less than. So we set up our problem and say, cool, it means what's inside here is between -1 and 1, and now we're just going to simplify this in this expression, that's the word. Let's take away 2 from everything. So we get -3 here and we get -1 here. Let's get rid of those negatives because they're bumming me out. Let's make everything positive and smiley. Don't forget, when you change the sign, so I'm multiplying everything by -1, so these less than signs are going to turn around and become greater than signs. Now we will divide by 5 and we get 3/5 is greater than x, which is greater than 1/5. And this is not how we typically like to write our inequalities. We like to have the smaller number on the left and the bigger number on the right. So we'll just flip that stuff around and say that 1/5 is less than x, which is less than 3/5. Or the way you can just read this is x is between 1/5 and 3/5. Okay, those are the basic examples. Let's kick off with some challenge questions to get the blood pumping on this beautiful Saturday. Okay, first one is x squared is less than or equal to the absolute value of 2x minus 1. So whenever you have an absolute value, you're going to be working with two cases, the positive case or the negative case. Case 1 is that what's inside here is already positive, which means the absolute value doesn't change it. Okay, when what's inside here is positive, the absolute value just gives you what you put in. So we end up with this quadratic inequality, which we'll solve like before by putting everything on the left. So we have x squared minus 2x plus 1 less than or equal to 0. We can think about this quadratic by factorizing it and getting x minus 1 all squared, because two numbers that add to -2 and multiply to positive 1 are -1 and -1. If we think about the parabola x minus 1 squared, it's only got one axis intercept, which is just at x equals 1, which is why it looks like this. It's a parabola that's been shifted 1 unit to the right on the x-axis. So if we're asking ourselves, where is this parabola, this green thing here, where is this less than or equal to 0? Well, it's never less than 0 because it's never passing through the x-axis and going into the negative zone. It's always positive up here. The only place it's equal to 0 is at the x-axis intercept, which is right there at 1. So there is our only solution from this quadratic inequality. We don't get two numbers that we're between or outside. We get one number that we are on. That gives us a 0. Okay, that's case 1. Case 2, a bit spicier, is what's inside your absolute value is negative, which means the absolute value is going to give it another negative to make it positive. Okay, imagine inside here was like -2. If we do minus 2, we get positive. So this is how the absolute value always spits out a positive value. If it's positive, all good. If it's negative, we'll give it another negative, so now it is positive again, and that's how it works. So now we are going to solve this quadratic inequality. Let's expand the right-hand side to get -2x and +1. Let's chuck it all over on the left, and we've got this parabola, concave up parabola, less than or equal to 0. Like we saw before, when you have a concave up parabola and you're looking where it's less than 0, you're going to be looking between the two x-intercepts where it dips below the x-axis. Unfortunately, this little boy cannot be factorized, which means we're going to have to complete the square, or let's just cut to the chase and use the old-fashioned quadratic formula. Negative b right here, we've got b squared here, 4ac all over 2. Inside your square root simplifies to the square root of 8, and the square root of 8 can be simplified to 2 root 2. And now you've got a fraction where there's a 2 here, and a 2 here, and a 2 here. So we can just cut everything in half and just write it as -1 plus or minus root 2. Okay, these are our two x-intercepts. The first one is going to be the negative root 2, and the other one's going to be the positive root 2. And so because we're looking where is this parabola less than 0, it's going to be between these two values. So putting that all together, we have that, here we go. So either x is between the two x-intercepts of this parabola where it's less than 0, or from before, from the positive case, we also have the solution x equals 1. So both of these are valid solutions to this problem at the top. Okay, that was fun. Let's kick it up a gear and do another one. All right, 3 minus x is greater than 1 over the absolute value of x minus 4. Oh boy, this is fun. So this is a bit of a prelude to the next video, but when you're solving inequalities, you have to be really careful when you're multiplying by x, because quite often you don't know whether x is positive or negative, and that means you don't know whether this sign here is going to have to turn around. However, the absolute value of x minus 4 is always going to give us a positive value. So this thing right here is positive, which means we can multiply it across the left-hand side, and we know that sign doesn't turn around. It's all good. Okay, so you don't have to worry about that sign turning around because this guy right here is positive. Okay, just like before, we're going to have two cases. Either this is going to give us the positive version, or it's going to be negative, and so we've got to give it another negative to make it positive. Okay, so case 1 is that x minus 4 is already positive, and so it just turns into x minus 4. Now we are going to solve this quadratic inequality. Let's do a bit of expanding like this. Let's bring the 1 across, and let's just tidy it up a bit. So we got minus x squared here. 3x plus 4x is 7x, and minus 12 minus the 1 across is minus 13. Greater than or equal to 0. Okay, like I said, I always like to make my x squared positive because it just helps me get to sleep at night. I don't like negative x squareds. I like them nice and positive. Now, so I'm just multiplying everything by -1 there, which means don't forget to turn that inequality sign around because you're multiplying by a negative. Now, this is tragically unfactorizable, which means we're probably going to be using the quadratic formula again. However, I'm going to save you a bit of time today and say that if we use the quadratic formula, this would be our discriminant, the bit that's inside the square root. B squared minus 4ac is going to be 49 minus 4 times 1 times 13, which is -3. That tells us that the quadratic formula gives us no answers, which means this quadratic has no x-intercepts, which means it's never going to be less than 0 because it's never dipping underneath the x-axis. So we say no solutions, the parabola is never below the x-axis because it's got no axis intercepts. So case 1 was a bit of a bust, nothing came from this. Let's try case 2 where x minus 4 is negative. So important with the setup here is we say, well, if x is less than 4, that means that x minus 4 is less than 0. And if x minus 4 is less than 0, what's inside your absolute value is negative, which means we've got to give it a negative to make it positive. Okay, that's what the absolute value does. When what's inside is negative, it gives it another negative to make it positive. Hopefully that is making sense to you. So that means if we make this negative, we're going to have a negative x here, and we're going to have a positive 4 here. So we're just rewriting this expression here with a positive 4 and a negative x. So this is just the negative version of this. Okay. So keep in mind, this is only going to be valid if x is less than 4. That's the whole thesis of this argument in red. So now we're going to solve this quadratic inequality. Let's do some expanding once again. Similar to before, but a little bit different. We're going to have the x squared. We've got the minus 7x here, and we've got 12. I'm going to minus the 1 across to make it an 11, and we've got greater than 0, already a positive parabola. Concave up parabola, I should say. Okay, now once again, this is cannot be factorized, so we're relying on our trusty friend, the quadratic formula, which we're going to do over here for a bit of room. So minus b at the front, b squared minus 4ac all over 2 times 1. Simplifying inside the square root turns into 49 minus 44, which is 5. So we get two values here. One of our x-intercepts is 7 plus root 5 over 2, and the other one is 7 minus root 5 over 2. Because we are seeing whereas this quadratic, this parabola, greater than 0, like we saw before, parabolas are greater than 0 if they're concave up when you are outside the two x-intercepts. So you're looking at the arms, okay? So normally we would say we're going to be less than the first x-intercept, so we're on the left of this and we're on the right of this. However, the extra trick to this question, which makes it extra spicy, is that at the very start, we made a note that if this is negative, which is what this whole case is about, if this is negative, then x is less than 4. That's an issue because 7 plus root 5 over 2 is roughly like 4.6, I think. So this value right here doesn't work because it's greater than 4, and we said, hang on, this whole thing only works if x is less than 4. So this solution here is actually invalid, which is the trick that makes this question much more challenging. And we say this is the only valid solution, this one does not work. So our final answer is x is less than 7 minus root 5 over 2. This one doesn't work because of this. Hopefully that makes sense. It's a pretty hectic question, but yeah, that's maths, baby. All right, that is the end of the video. Thank you very much for watching, and hopefully you tune in for part 2 in a week or so when I get some time to talk to my computer for a bit. Okay, hope you're having a great weekend, and I'll catch you in the next video. Bye for now, not forever.